So we are here to conduct some descriptive analysis. Then we go inside the script folder. Before we open data distribution analysis, now we'll open descriptive analysis. Right click on descriptive analysis. First left click, select, then right click, open with RStudio. So I have here all the script. We need to load these programs. Before install, lubricate, ggplot2 we did already before, and vegan must be installed. As usual, from package, install, and then here write the name of the program, install. After installing that, we have to load it by library. So 1, 2, 3, no error, set VD. I would like to select this folder outputs descriptive analysis because I want all the output results and figure will be stored inside this folder. Select the folder, signal stop, wait, okay. Now we are ready. Now we need to load data. Which data we go to load? Remember, this is to choose the file. The same data we load for to check the data distribution, because as I told you, that was ready for me with a lot of species and data and suitable to make some analysis. So even it's not Asian data, doesn't matter. So metadata gr sampling35, I will open it. I will head it to see if it looks right. It is. I remind you, if you start to find the separator, like dot and comma here, just add here, like I told you, comma, sep equal, and the symbol. So I will read it correctly, but in our case I read already correctly, so we don't need it. Just leave as it is. Now, our analysis can start. Seasonally activity, extract amounts from the data columns, proceed, and see later what will come. Through a plot. No error, just run the script, write the CSV, already we've wrote the CSV file, and then see if plot would be correctly. We need to load the ggplot where we did before, and monthly plot. Print the monthly plot. Okay, as you see here, we got something from January to July, because our data cover from January to July, about the number of detection species occurrence by month. So we saw that most of detection were done in June. Less in July because we didn't work full months in July and January, and the other month is quite close, between 550 likely to 700, whereas is over 1,200 in June. So at least we already, as you see, get an idea with the same camera, the same efforts, how the detection number change. That's already useful because we understand what is the month with the most activity, at least for some of the species. We can later investigate for which species, if all or only some, that has a lot of detection. But at least we get a rough idea. So that's why it is important to know it. You must know also that you can export your image by export from plot, save image, give a name like species by month, the directory, the exploration description, but I can do deal with camera. No, I want this one. Yeah, it's our current directory. Okay, and save. So we saved this chart that anyway should be saved. After all, we will save the plot to a file. So we are going to save anyway with this. But this is another way to save it directly with export. Okay, anyway, we save, and the first result is obtained with no error. Now, a diversity matrix. What we are going to do? Calculate the species richness through the Shannon index, which is a Simpson index. So are all the how to say species richness, species diversity index. Let's run it without trouble, hopefully. Let's see. Okay, from the console you see no error coming out. Well, calculate the index, the diversity matrix, write CSV with the result, and print it. Okay, now we got this result for species richness, Shannon index, and Simpson index, and then it will be saved. Then we go to species distribution by station. Again, run it, and save our CSV in our working directory. Then we do a special species relative abundance index, give us an idea of the species abundance related to our sampling effort, which is 480 days here. Then let's calculate it. Run, and run. We got a CSV with the species relative abundance of each species. Finally, a species accumulation curve. Now we'll see. Run. Okay, it's a warning, but how you see from the plot, the species accumulation curve come out. Again, we can export it in the same way. Pick back the expression. Okay, save. Okay, so we got now all the result. What is the species accumulation curve? Is for the accumulated effort here in the x-axis and the species richness, which means not the abundance of individual relative abundance index, but the number of species growing according to the sampling effort. So as you see at the beginning, immediately we got actually a good number of species over 10, growing. After a certain point, that is almost asymptotic to the x-axis, which means that the number of species grow very slow. So this is what the species accumulation curve tell us. Now your sampling can even stop because the species you will detect will be very small. Now let's see our output. If I save it in the right okay, this is what I saved manually. Do you see? Species accumulation curve and species by months. Descriptive analysis. Well, as you see, all the outputs we create are here. Then we have the diversity matrix, open. Simply, as you see in the preview, we have the metric values, species richness, Shannon index, and Simpson index. The value here is here. But my Excel take really long to open, even for such a small content. Little too long. Oh, finally here we are. So you will get this. Then we check also months species count. We can rename the column. We can remove this column actually by right click on A, delete, and then the variable we can call simply month. Okay, let's do it. We remove this column. We call this species, and frequency is fine. So it tells me basically that for each species, like this one was detected in January this number of time, February, March, until July, August, September. You count all the months, but clearly we know that we don't have data for August, September, October, November, December, so it will be always 0. But it's useful for all months up here, because if we don't have detection, anyway, it's good to know. Then Antidorcas marsupialis Springbok in this case. We have all this stuff. Do you see what I said? In June we got detected a lot of Antidorcas marsupialis. That's why it's a bit outlier. And given in the graph the June as a peak. And the same is for bird. We give in January a lot of detection. And also in June. So compensate. And then all the other are more limited. Here many other species. Later from this you can detect your chart and whatever you want. So something else we got, I could save actually, is the species distribution by station. Again, here I give you the station, the species, and the number of detection for each species in each station. So also here we could do, for instance, here the station, here the species, and just cross the species with each station detection. So we have for each species, each station. Fine. Then, that is the graph we saw before. Then, species relative abundance index. For each species, which in this case are 45, so including change, I thought this is human, change when we go researcher, we go with our board to change the SD. This is Homo sapiens, this is birds generic, but the other are all species. So we have simply the relative abundance index value. This is species. And this can be removed. So now yes, we can save it. So, as you see, we got basically all we need to know, with also these two chapters, the species accumulation theory and the species occurring by months, that later we can sort in a different way with other beautiful chart, with beautiful table, combining better the column and the row, even by arrow or by hand in Excel is quite easy, straightforward. But we got all we need for have a clear idea of our data, how they're distributed, which kind of analysis we can do. We did it for all the species in one table, but we can do it for single species or couple of species to understand how they're distributed and which kind of analysis we can apply. Plus, we also saw descriptive analysis to have a rough idea of the community, in this case the mammal community, and how data are distributed by months, by extension, that are still important inputs. From next, we start get to more complex results, but the analysis will not be such complex. You will see. Bye, I'll see you the next.